up, class? Today we will be covering polynomial long division. Alright, so we'll start with long division and then we'll transverse into synthetic division, but let's get long division down first. We're going to do an example. It says find the quotient and remainder for 2x to the third power minus 5x plus 9 divided by x minus 3. Now, when I set these up, whether it be by long division or by synthetic division, what I like to do is make sure each one of the powers of x is represented. Now, to set it up as a long division, I'm going to set it up as if we were actually dividing these. So I'm going to take the x minus 3, and then I'm going to write a dividing symbol here. And then I'm going to write what was in the numerator there, the 2x to the third power. The only difference here is I'm going to add in a 0 for the x squared here. Then subtract the 5x and then add the 9. Because I want each of the powers of x to be represented. So if I start with an x to the third, I need to see an x to the third, an x to the second, an x to the first, and then technically an x to the 0 as well. So I want to be able to see all my terms. Now, when I come through, what I'm going to do with this is I need this front x value here to equal this value so that it would cancel out. Now, in order to do that, if I want to make an x into a 2x to the third, I would need to multiply this x by 2x squared. Okay, so that's what I'm going to do. 2x squared times x would be 2x to the third. And then 2x squared times negative 3 would be negative 6x squared. Now you can kind of see here why I wanted to add that x squared here even though it had a 0 in front of it. Now, just like doing long division with basic numbers here, we're going to subtract off this term that we just come up with. Okay, so that's why I put parentheses around it, because we're subtracting off that entire thing. So 2x to the third power minus 2x to the third power gives you the 0. And then 0x squared minus a negative 6x squared gives you a positive 6x squared. Now you just bring the rest of your terms down. So I'm going to bring down a negative 5x, and I'm going to bring down the plus 9. Now I want this x to turn into a 6x squared. Okay, in order for that to happen, I need to multiply it by a 6x. Okay, so 6x times x is 6x squared. 6x times negative 3 is negative 18x. All right, once again, I'm going to subtract this value. Now 6x squared minus 6x squared is 0. Negative 5x minus a negative 18x should give you a positive 13x. And then I'm going to bring down the plus 9. Now I want this x to turn into a 13x. So I need to multiply it by 13. That's going to give me a 13x minus 39. Okay, now we're going to subtract this and see what we get. 13x minus 13x is 0. 9 minus a negative 39 is a positive 48. Now at this point I can't turn an x into a 48 because there's no x term with it, so I'm done. My quotient here is the 2x squared plus the 6x plus the 13, and my remainder is the 48. Simple enough. Okay, so that is how we would do this if we were to divide and do the long division. Okay, just like you would if you were using numbers essentially. Now, let's look at the same question, but let's instead use synthetic division here. Now, when we use synthetic division here, one of the things we have to recognize is that what we want to do is we want to take this denominator, this x minus 3, we want to set it equal to 0. Okay, and when we do that, we see that we get an x equals 3. Okay, for a synthetic division, what we're going to do is we're going to set it up like this. We're going to take that 3 and then we're going to set up a bar here. Okay. Now we're going to take the numbers out in front of our x's here and our constants, and we're going to set those up. So we're going to set up a 2 in front for the number in front of the x squared, or the x to the cubed. We don't have a number in front of the x squared, so we're going to put a 0. We're going to put a -5 for the number in front of the x, and then we're going to put a 9 for our constant. All right, now here comes the mechanics of synthetic division. Okay, we're going to bring down the 2 to get started. Now 3 times 2 is 6. Okay, 6 plus 0 is 6. 3 times 6 is 18. 18 plus -5 is 13. 3 times 13 is 39. 39 plus 9 is 48. Okay, now our numerator had a highest x value of x to the third. Okay, we're going to step down 1 from that. Okay, because we divided off 1x. So we can now write this as 2x squared plus 6x plus 13, and then that would be your quotient, and 48 would be your remainder. And if you check with what we found with synthetic division, you see it's the exact same. Okay, so either one of those methods works just fine. Now, let's find the quotient and remainder for this one. Be my guest, choose whichever way you would like. Okay? For this one, let's see, which way did I decide to do this one? All right, for this one, let's use synthetic. If you want to do long division, by all means, be my guest. But let's use synthetic division. Okay? Because if you get synthetic set up and you get good at it, it goes a lot quicker. Now, if I look at my denominator here, the x plus 2, if I were to set that equal to 0, I would see that x equals -2. All right? That means I need to have a -2 out in front on my synthetic division. Now I'm going to go through my x values here. Here I have a 6 for my x to the fourth, a -2 for my x to the third, a 1 in front of my x squared, a -3 in front of my x, and then a 1. I'm going to start by bringing down the 6. 6 times -2 is -12. I'm going to add those two numbers together. -12 minus 2 is -14. -2 times -14 is +28. I'm going to add that to 1. That's going to be 29. -2 times 29 will be -58. Okay. -58 plus -3 here. That's going to give us -61. And then, just want to check the number here. So, okay. And then we're going to do -2 times -61 will give us a positive 122, I believe. Yep. So, positive 122, which we need to add to that 1, which gives us 123. Okay. Now we just have to rewrite it. We're going to look at our quotient and our remainder. Remainder here should be 123. Our quotient here, we had a 6x to the fourth power, so I need to step down to an x to the third power. Okay, so this is going to be 6x to the third power minus 14x squared plus 29x minus 61. We have successfully isolated our quotient and our remainder. Now let's look at the remainder theorem and what it says. All right, for our remainder theorem here, it says that if f of x is over d of x, then it should equal a quotient q of x plus a remainder r of x over d of x. Now, what that means is if we were to solve for just that f of x factor here, which would mean that we would basically multiply this whole thing times d of x to get rid of the d of x in the denominator here, we would wind up with a q of x times a d of x plus an r of x, because the d of x would cancel here, because we're applying it to all three terms, but it wouldn't have anything to cancel in with the q of x, so it would stay there. Now, if our d of x was equal to x minus c, okay, so if I'm going to let d of x equal x minus c, follow me real quick. I'm going to plug in d of x when it is x minus c, okay? So I'm putting an x minus c in for d of x. All right. Now, if I were to do that, and then I came across a case where I was trying to find f of c, well, f of x equals q of x times x minus c plus r of x. So if I plugged in a c for x, this would give me q of c times c minus c plus r of c, where c minus c is 0. So I get q of c times a 0 plus r of c. Anything times 0 is 0, so it would simplify down to an r of c, which means that f of c would equal r of c. Fair enough. What it essentially means is if I wanted to find f of a certain value, I could just plug that value into synthetic division. Whatever the remainder value is that came out of that would be the actual value of f of x. Okay? What that means is if you have a situation like this where it says given f of x equals x to the third plus 3x squared minus 4x plus 2, if you wanted to do it the long-term way and find f of 1 plus the square root of 2, what you would have to do is you would have to plug in 1 plus the square root of 2, cube it, add that to 3 times 1 plus the square root of 2, square it, subtract that from 4 times 1 plus the square root of 2, and then add 2. Or we could use synthetic division to find that particular value. Okay? If we use synthetic division to find that particular value, all we have to do is take that value, the 1 plus the square root of 2, use synthetic division, so we'll set it up just like a synthetic division. We'll have a 1 for that x cubed. We'll have a 3 for that 3x squared. We'll have a negative 4 for that negative 4x, and we'll have the 2 for the constant term. Now, if I were to work this through with synthetic division, I would bring down the 1. I would say 1 times 1 plus the square root of 2 is 1 plus the square root of 2. Okay. If I would add 3 to that, I would get 4 plus the square root of 2. Now here, it does get a little bit more work here, but now I have to multiply 1 plus the square root of 2 times 4 plus the square root of 2. Okay, we can do this. 1 plus the square root of 2 times 4 plus the square root of 2. Well, 1 times 4 is 4. 1 times the square root of 2 is the square root of 2. Square root of 2 times 4 is 4 square root 2. And the square root of 2 times the square root of 2 is 2. If I were to simplify that, it would simplify down into 6 plus 5 square root 2. So that's what needs to go here. 6 plus 5 square root 2. Now, I need to add to that negative 4. Well, that's going to give us a 2 plus 5 square root 2. And now I have to multiply that times 1 plus the square root of 2. Okay, well 1 plus the square root of 2 times 2 plus 5 square root 2. Let's see, that's 1 times 2 is 2. 1 times 5 square root 2 is 5 square root 2. Square root of 2 times 2 is 2 square root 2. And square root of 2 times 5 square root 2 is 5 times 2. Okay, well that's 2 plus 7 square root 2. And 5 times 2 is 10, which means this should simplify down to 12 plus 7 square root 2. All right, that's 12 plus 7 square root 2. Let me write this nicely. 12 plus 7 square root 2. Okay, now if I add that to 2, I wind up with 14 plus 7 square root 2. What that tells me is that, I'll change colors just so it stands out. That tells me that f of 1 plus the square root of 2 equals 14 plus 7 square root 2. You're like, well, that was kind of a bit of work here. I had to do a little bit of work here and do a multiplication. I had to do a little bit of work here and do a multiplication. Would it be easier just to plug it in? Well, you may think that. But if I were to plug this in, just as I tried when I started here, if I would have tried to go through the simplification steps here, I would have wound up having to multiply 1 plus square root 2 3 times. And then I would have to multiply 1 plus square root 2 another 2 times. And then I'd also have to multiply it by that constant 3, and then over here times that constant of negative 4, and do additional additions of adding all that together. So is it simpler in this case? It kind of is simpler to do the synthetic division, especially if you're wanting to keep it in terms of these square roots, because your calculator could do this really, really quickly, but it will not keep it in terms of the square root. We need it in terms of the square root. So we can use synthetic division to kind of simplify that process to find individual semi-complex values here. And that completes today's lecture. If y'all have any questions, send me an email. Other than that, I will see y'all next time.